All right, had a good morning tea break, guys. You were probably, that's all right. We're in Fiji time today. All right. I don't think I need to ask this question, but I'll point the finger to Brian. Brian, why is it important that we clean when we're taking pipes off of injector and pulling things apart on the diesel fuel system? Why do we have to be clean?
Because if there's some little dirty in the diesel fuel system, it will it's not good.
And why is it not good? So because there's such high pressure in the particularly common rail diesel, right?
Yeah.
Any little bit of particle that's in the very fine tolerances of the injector or the injector pump, because they've got very little clearances, right? Anything like of abrasive nature will be twice as bad because of the high pressure and can do some damage, okay? It can put tracks and marks into things that should be nice and shiny and sealing properly, right?
Yeah.
So it's important to have everything clean. How do we service a sediment bowl? We didn't talk about it, but I'll ask. We did talk about the sensor on one. You know what I mean by sediment bowl? Sediment, the sediment that settles in the bottom. How do we service that?
On an injector?
On a, say, a filter or a sediment bowl. Some
filters has got, underneath it has got a screw, a drainer thing where you can drain the water, all the sediments at the bottom.
Yeah. Sometimes we've got to actually change the filter. Sometimes we can manually clean it out. Sometimes there's a bowl we can take out and clean it out. So
and if it's tank, then you can drain the tank and clean it out.
Yeah. I had there's I won't bring it out now, but there's a pump in the back room there from a Mercedes Sprinter. It was a brand new car, virtually that year it was built. Someone put contaminated fuel, it's full of water, and it contaminated the whole system. We had to change the fuel tank, we had to change the fuel. Actually, we might have cleaned the fuel tank out. No, we did. We changed the fuel tank, we changed the fuel filter, all the pipes, the injector pump, the injectors, everything we changed because of the fuel contamination.
Just a quick question.
Yes.
How does it contaminate the tank? Is it not washable, or like if it goes in the tank, like is there any sensor or anything on the tank?
I probably didn't tell you the full story about this car. It also bent a conrod. The water is not, when it comes up, the piston comes up and if it can't compress water, something gives and it bends the conrod. Now you get low compression, right? So it needed a new motor, and there was no way, because it ended up going through insurance, and there was no way the insurance company would let me take a risk on any of those parts. So we just replaced them all, okay? Yeah. Sometimes we do clean them out, I agree, but yeah.
No, I thought that there must be a sensor or something on the tank, like once it's contaminated with the water.
The tank's got a little baffle plate, so as much as you try and clean it out, you might miss some, and there's no way they wanted to risk another contamination because we didn't clean it out properly. Okay, how is the warning light switch on a sediment bowl checked? You know how we looked at the plug on the bottom of the filter housing?
Yeah.
How do we check that that's okay?
With the multimeter. On meter,
We just physically test it that way, how can we know if we've got a faulty injector? How can we locate a faulty injector?
Doing a return check.
That's one of the ways, yes. Yeah. We'll probably learn some more things about
it.
Sorry?
Or some of the scan tools has got a provision where you can go and turn off individual injectors using scan tool.
It may not be possible with all diesels. I can't remember seeing a diesel.
No, I've done,
fair enough.
Yeah, I've done it.
But it'd have to be a solenoid type. I'm thinking of common rail diesels too. All right. What type of equipment is needed to service injectors?
injector pressure test or the
We saw that on the bench one or that little pump up one. What safety precautions should be observed when checking a spray from an injector?
always you wear the goggles, gloves.
Yeah.
So make sure you don't touch the spray.
Yeah. Are we going to do a common rail diesel injector test, one like this one down here?
Yep.
Are we going to test that? Can we hook that up to the engine, pull it out, hook it up to the engine and run the engine?
No.
No.
It'd be too risky because of the high pressure, okay? So we need a special bench.
Roughly how many kPa they're working on?
Around I think 30,000 to 35,000 on the
at idle about
at idle.
30 to 35,000, but it goes right up to 140 or 50,000.
So they're that powerful that they can go through your skin and come out the other way?
Definitely. Is that still recording?
Yes. Yeah.
Phone call, yeah. People keep ringing me. All right. What else? Safety precautions. Yeah, we've done that one.
Number 8.
What are the likely causes of black smoke from the exhaust on a diesel?
Unburned fuel.
Yeah.
Fuel and carbon.
How we haven't talked about this. How is a compression test carried out on a diesel engine? How do we do it on a petrol engine?
So we take out the spark plug and put a compression test
Exactly.
on.
Oscilloscope.
We can do that, but let's do a physical one now. How do we do a physical compression test? What would we pull out to do a compression test on a diesel?
We can do a injector
You can.
or the glow plug.
Glow plugs are the more
Yep.
common way. Okay, we remove the glow plug and do it. And do we just use our normal petrol compression gauge to do a compression
No.
test? No? Why
Has to
not?
be a diesel.
Why is that?
It's got a very high pressure.
100%. Okay. And yes, I would do what's called a relative compression test on a diesel before I do a physical one.
Yeah.
Much easier, isn't it, to do that and quicker. Lastly, how are fault codes accessed on the injection system of electronic control injection pump? Or even common rail for that matter.
How are fault codes accessed on an injection system with electronic control? Scan tool.
Exactly. Yeah, 100%. That was a pretty no-brainer, wasn't it, that answer? That question. All right. Let's move on. So, looking at the fuel system as a complete, we've got our fuel tank, okay, that runs fuel through our filters. You can see our fuel filters, then goes through to the injection pump. And usually there would be a pump inside the fuel pump, generally speaking, which is, we call sometimes a lift pump on a diesel. We call that a lift pump. Because it lifts the fuel from the tank to the actual injection pump.
Or they call it auxiliary? Auxiliary pump.
I know that video we saw earlier had 2 pumps.
Yeah.
So that's interesting. There's a electronic, it's a mechanical injection pump system, okay? So we start from the fuel tank. We start from the fuel tank, goes through the sediment. See, there's a separate
Sediment.
filter. And then we come up to there's a fuel pump here. So it may not have a fuel pump here, it might just have one there, through the fuel filter, into the injector pump, and then to the injector, fuel pump to the injector, and then there's a return line. There's also a return line on the injector pump. There's 2 return ports. There we go. So,
Just a quick question before the slide on before. Why do they have a return or that's an overflow? So like if anything,
so
if it produces much pressure, then it's going to return through that.
I'm going to take a guess here. There's a car solenoid. I'm thinking there might be a load limiter.
Oh, okay.
But there must be a reason for return fuel. I don't really, can't be sure why. I don't understand the injector why, but the pump itself, there have to be a reason.
Isn't it not that
Maybe it's a regulated pressure
in the
put
pump?
out to return. That's the only thing that would make sense to me, but I don't know. I could be wrong. Okay, there are a number of different types of injection systems for diesel engines. The main differentiating factor being the pump type. Some are electronically controlled, but the types of fuel systems that we'll see, there's a distributor type pump system which is fairly common in the older diesels that we see in small cars, light vehicles, and the common rail. They're about the two that we're going to see mostly. Inline injection systems, I did see a little bit of that back in the 80s and earlier, particularly in the Land Cruisers and stuff. They had straight line injectors, right? And uni-type injected systems, which I haven't seen much of, okay? But we'll just go over a couple of those. So that's your straight line injection. See how each injector is in a line, okay? So that's probably less common nowadays. Maybe in medium-sized or bigger trucks might be common still, but not in our smaller light vehicles. What's a uni-type injection pump? I didn't know. That's to be the truth. I didn't know. So I'm learning today too. So I did a bit of a check and I have got a video about what they are, so we all know.
The established unit pump systems and unit injector systems are suitable for use in large engines generating up to 350 kilowatts per cylinder. The systems achieve a low fuel consumption by preparing the mixture efficiently to subsequently improve combustion. This can contribute towards compliance with emission regulations. The electronically controlled injection pump UP, installed on each engine cylinder on the unit pump system, has a high-precision design that guarantees the reliable buildup of pressure. The nozzle holder assembly is responsible for injecting fuel. The unit injector combines pressure generation and injection in a single compact component. The start and duration of the injection can be adapted according to requirements, so that the quantity and pressure of the fuel is adequate even at low speeds. The electronic engine control unit controls all component functions on both systems.
It sort of reminds me of the coilover plug, everything all together, and the injector and the pump all joined together, right? It's not a bad concept, whether we see that in our smaller...
But they only use in high-powered engines.
It looks like it, yeah.
Yeah, that's what they said.
Yeah, I know. But yeah, that's what they are. Yeah. Okay, our most common earlier model injector system pumps were like this, like a distributor type with the round back with all the pipes coming out of the injector pump, okay, before we went to common rail. And there were two types. There's the axial pump and there's the radial pump. The difference being is the way they pump the fuel up, okay? So the axial pump is pumping fuel through a concentric plate, and as it rotates it pushes plunges in and out. Whereas this rotary pump is using a rotor on there. See that rotor on there that's got an offset so that it will turn the plunges up and down to pump. So we'll have a bit of a look. I won't read through all that, but we'll have a bit of a look at them on this short video to help you understand.
Axial piston pumps. In axial piston pumps, the pistons are parallel to the axis of rotation of the shaft, or slightly inclined at an angle of not more than 45 degrees. To pump fluid, the pistons in the pump must move forward while the drive shaft rotates. Converting the rotational motion of the input shaft into the translational motion of the pistons is possible due to the inclined position of the bent axis, or the swash plate on which they rest. In the first case, the device is called a bent axis pump. In the second case, it is a swash plate pump. Let's try to figure out how these pumps can pump fluid. First, let's check the pump design. Let's take an adjustable bent axis pump as an example. The pump housing has a distinctive curved shape. and its shaft is supported by bearings. The pistons are attached to the shaft with spherical bearings and placed into the inclined block mounted on the axis. In the pump shown, pistons are used to transmit the rotation from the drive shaft to the axis, while some other devices use cardan shafts as a drive unit. The block is supported by a valve plate that has a spherical surface. The plate has channels for supplying and discharging fluid to and from the pistons. The fluid leaves the valve plate and then enters the cover that has an inlet and outlet opening. The fluid from the tank is supplied to the inlet channel of the pump, from where it is sucked by the pistons. Consider the operating principle of one of the pistons. When moving through the suction area, the piston moves and increases the volume of the working chamber. Due to the increase in the volume of the chamber, the pressure in it drops and the fluid fills the chamber under atmospheric pressure. Having reached the extreme position, the piston begins to move in the opposite direction, thus reducing the volume of the working chamber, and the fluid is displaced into the pressure channel. Having reached the second extreme position, the piston begins to increase the volume of the chamber again. The suction begins, and the cycle repeats. Several pistons are installed in the pump housing. There are 7 in the example provided. While one piston performs suction, the other is pushing the fluid into the pressure line, and the third is in the extreme position. This design allows for a continuous supply of fluid with relatively low pulsations. The presented pump does not need any check valves, since its pistons always suck in one area and discharge in another.
Radial pumps are designed so the pistons stroke in a direction at right angles to the shaft. The pistons are arranged like wheel spokes around a cylinder block with an eccentric central cam mounted on a drive shaft. As the shaft rotates, the cam moves towards the pistons, forcing them down into the cylinder block and discharging the fluid. As the cam moves away, springs help retract the piston and cause the intake stroke. Check valves ensure that fluid only enters the inlet ports and only exits the outlet ports. Radial piston pumps have a low noise level, very high loads at low speeds, and high efficiency.
Okay, what are the 2 types of pumps that are built into the injector pump? Obviously that video wasn't injector pumps, it was just giving you the concept of the pumps, right? So we have an axial type pump and a radial pump, and so that's the only difference is the way they pump the higher pressure for the injectors, okay, the injector pump. So it's good to know those things. So we move on to common rail. This is where we're at today. This is what you'll see now is mostly common rail. Common rail is called common rail because there's a rail that is common to each of those injectors, and that's where the name comes. It can also be called accumulator. Okay, an accumulator. It accumulates the diesel for each injector in there, right? And it holds the pressure in there, so it can be called that as well. And we see that we've got a different pump from what we just saw. Okay, we'll learn about that pump a bit later. But this pump here is a much higher pressure pump than the earlier injector pumps that we looked at. Okay, and it will pump up to the rail. So anything else coming out of the pump is high pressure. So everything in the pressure, in the rail and in the injectors, going to the injectors is high pressure. All right. Do we loosen up a pipe to see if the engine is running okay? To see if it's misfiring? We don't, do we? No.
Because it's under pressure, we can't do that.
That's right.
But we do that.
Guess what happens if you do it?
Nothing.
The engine stops.
Yeah.
So in a way, it's got to be careful how I say this, but it's not quite as likely to splurge and get diesel in you under high pressure, but is it worth the risk? Everyone says don't do it, so don't do it.
Don't do it.
Okay.
Everyone does it.
Right. Why do you think it cuts out when you undo the pipe?
Lose pressure.
Yeah, once you lose pressure, the pressure sensor in that rail tells the computer there's no pressure, and it kills all the injectors, and it cuts out. But anyhow, not every diesel has a pump in the tank, but a lot of them do, and they call that a lift pump. fuel supply pumps. All diesel systems have some form of supply pump that takes fuel from the tank and delivers it to the injection pump, or in some cases, directly to the injectors. The vane pump, the diaphragm pump, the plunger pumps, and the gear pumps are all used, but dependent on the type of system. So there are a range of different types of pumps for the common rail diesel, okay? So it can be any of those sort of pumps. And I've seen a few different ones, okay? There's a handy hint down here. Pumps that supply low pressure fuel are referred to as supply pumps or feed pumps, lift pumps or transfer pumps. So there's 4 different names that people will call those pumps in the tank. I just like to call them lift pumps. That's just what I've gone with. But yeah, you can call them any of those things. Or if you see any of those words written down on any of your technical data, you know they were talking about low pressure pump, okay? Different to the high pressure pump. So, here's a vane pump. The vanes in there, I'm pretty sure as they turn, they come in and out because of, see how we've got a area here, and this is turning, and those vanes go in and out, and that's causing the fluid to circulate and pump through as it circulates, okay? All right. We also have a prime pump. Who talked about the prime pump yesterday? Today, yeah. So that's a prime pump. I told the story yesterday that I put petrol in my car once instead of diesel, and I didn't start it, fortunately. And I pumped all my petrol, full tank by the way, out using that pump. And it hurt your hand after a while, eh? Pump.
Actually, what I do is the line that's coming from the tank and that's going into the engine, the feed.
Yes.
So you plug the line that's coming from the tank.
Yes.
Then you hold that's going to the engine. You don't plug it back. Pump, get all the air out. When the diesel come out, plug the hose and crank the car.
Guys, go back to that one again. I've had cases, by the way, where these leak air into the system, so you have to replace it sometimes.
And they have the spin-on filters on them.
They do, that's right. Okay. So, there's one of our lift pumps. The common rail system often will use an electric pump. This is located in the fuel tank and supplies low pressure fuel to the main high pressure pump. The electric pump consists of electric motor with permanent magnets, fields connected to a roll cell pump. Fuel drawn into the pump passes through the body of the pump before leaving the tank. A pressure limiter in the form of a spring-loaded valve opens when operating pressure is reached. It limits the pressure of the low pressure side. So obviously they don't want a high pressure in the low pressure side, so we have like a relief valve, okay? Read all this on your notes if you want to go back and have a better look at it later. Okay, back to where we should be, common rail. So I was out of whack a little bit there before. So, our components for the common rail, okay? This includes the electronic control system as well as the fuel system. The system has a low pressure stage and a high pressure stage. The low pressure stage supplies fuel to the high pressure pump, injector pump, and the high pressure stage delivers fuel to the high pressure of the injectors. In addition to the ECU that controls the fuel delivery, operates the injectors and adjusts the injection timing. See this rail here? We're going to have a bit of a look at that, okay, in a minute, but we've got our feed in, we've got our feed out for the injectors, we've got a pressure sensor for the pressure in the rail, and often we have a pressure release limiter, so when the fuel gets too high, it will release some pressure. Again, here's a schematic of the common rail. I think we'll keep going. Okay. Common rail injection systems on the low pressure. We've got to realise the low pressure plays a big part of the high pressure. If we've got a problem with the high pressure side, we need to rule out the low pressure side. I used to have a little tiny fuel drum, a plastic drum, a bit like an outboard motor drum, you know, those plastic ones you pick up and walk around with. Had one of those set up. I used to have a primer pump that I could pump all the air and pump straight into the injector pump. I do away with the filter, do away with everything, and just go straight to the pump all the air out. I could then have another pipe that would go to the return line. I get the return line to come back to that tank, so I could control. I'd be the fuel tank then. I would be everything that the low pressure side is. And if my problem disappeared when I put that on, I knew I had a low pressure problem. If it didn't fix it, I would actually have hoses long enough to put in the floor of the car and drive the car on my remote tank, so I could test that I knew all the low pressure side was okay. And that ruled out anything on the low pressure side. If the car ran good, I would then go and work out what was wrong. Obviously I was getting air in the system, I had low pressure, all those things, right? Again, I do what was easiest first. Sometimes that was the easiest thing to do. Other times it might have been easier to check the flow pressure and maybe even put a clear piece of hose on the system. But yeah, low pressure plays a critical part. Something's wrong with the low pressure, it's going to affect the high pressure, okay? So the low pressure consists of the fuel tank, the electric supply pump, and the flexible tank and the filter sediment. And there are low pressure lines for supplying fuel to the high pressure pump and low pressure lines for returning the fuel back to the pump. The low pressure pump operates constantly to supply fuel to the high pressure pump at about 3 bar, okay? 1 bar is about 1000 kPa, so we're looking at about, oh, is that right? Bars 1000 kPa? Someone Google it for me. I get wrong sometimes. Better get this. I'll say the wrong thing. I work in kPa and I work in pounds per square inches. I hardly work in bar, even though...
1 bar is 100 kPa.
Yeah, you thought I got it wrong. That sounds better, doesn't it? Yeah, so 100 kPa equals 1 bar, so that's about 300 kPa.
Kilopascal.
Kilopascals, correct. Okay. Fuel flows through the pump and acts as a cooling mid. So the fuel actually helps to cool down the injection system, okay? And it goes back into the tank to cool down and come back again. Someone said yesterday some systems have a fuel cooler
14.5
to cool down the fuel, because that does get very hot from the heat of the engine and the combustion, right? So it's important to keep that fuel cool. Fuel from the pump reaches the high pressure pump after passing through the sediment and filter. Surplus fuel is directed back to the tank through the fuel return lines. Return lines are connected to the top of the filter, to the high pressure pump, and to the common rail and to the injector. So all those things are connected back as a return, okay? Make sense? Okay, now the high pressure. The high pressure stage includes a high pressure injection pump, the common fuel rail, that's the rail here, the high pressure fuel lines, the lines that go to the injectors, and the fuel injectors, okay? In this stage, the high pressure pump generates a very high fuel pressure and delivers it to the common rail. The pump is driven by the engine's timing chain or belt camshaft speed. The fuel delivered to the pump to the common rail is contained by heavy walled tubes. So you can't just have any old pipe, you can't just make up your own pipes for the injector pipe. They wouldn't last, they just burst. So they are very strong pipes. Individual pipes are connected to the common rail, to the injectors. All components in this stage of the system carry fuel at a high pressure. So that's where we have to be careful. That's why we talk about being work health and safety conscious of those things being under high pressure, okay? All right. Okay. The construction of the high pressure injection pump. The drive shaft, so the shaft that drives the pump, this is a eccentric, couldn't get the word out then. This is an eccentric that operates a cam, which then operates the pump piston. Eccentric meaning, see the piston up there? So that'll be like a cam light up and down, so pushing the piston up and down. A lot of this looks like it's driven by the gears, like in the timing chain, but a lot of high pressure pumps, I don't know about diesel, but certainly in the gasoline direct injection, are driven off the camshaft, and they use a plunger like that too. I think diesels are mostly driven off the front of the motor. The pump unit, this has 3 pumping elements, a piston, a pumping chamber, and an inlet and outlet valve. This unit produces a high fuel pressure. The element shuts off. This is an electric solenoid that isolates one of the pumping elements to reduce the pump output under certain conditions when lower pressure is needed. The pressure control valve, the solenoid operated assembly that controls the pressure of the pump. So obviously these pumps are a bit more simpler than the earlier injection pumps, but they still have a way of controlling pressure. They have a way of pumping, okay? A little bit different to the others. And you're looking at your book there, that's good, thank you. Okay, so that is the high pressure pump, and there's different types of high pressure pumps, the vane, the plunger type, and a few others that we'll see. So here's another type, okay? This is the pump operation. Low pressure fuel is a pressure pump through the pump inlet. We already know that from the last one I read. After being compressed, fuel is forced into a high pressure side pump. It then passes through the output port through the high pressure connection of the common rail. Pumping elements. This has 3 pumping elements spaced at 120 degrees between each other. This is like the radial pump. I couldn't think for a minute. So that's a radial pump. So we've learned all about that before. So the same system. The shut-off valve. Okay. The pump shut-off valve is a solenoid-operated valve located on the top of the high-pressure pump. Its function is to prevent the top element from developing pressure. It does this by energising the solenoid to move the pin downward. This holds the inlet valve to the top of the pump element open. The plunger continues its normal motion, but there is no pressure developed, so the fuel is disregarded through the outlet valve. The element shutoff is operated by the electronic control unit, which shuts off the element at idle and low speeds when less fuel is needed, as well as reduces the amount of fuel being pumped into the pump. It conserves engine power. So yeah, it does a lot of things, the shutoff valve, so it's very important, okay? Any questions about the shutoff valve? All pretty basic, isn't it? So it's just
it just shuts off.
It just dumps the fuel so it doesn't build up pressure. That's all it does. Okay. Okay. We have a pressure control valve, also known as a suction control valve. So it could be either of those names. They give a lot of trouble, injection pumps. They have a piston, like I call it a piston, I guess, a shaft, and that shaft moves with the actual opening and closing of this solenoid in and out, right? So it controls both, generally the low pressure and the high pressure, but particularly the high pressure, okay? And as we saw in that video before, he looks at the target, what the computer wants as far as the pressure in the system, the high pressure. So target pressure, and we look at we'll go downstairs later, we'll put up a scan tool, have a look at this on the highlights. And we want to look at the desired pressure, or target pressure, it's the same thing, and we look at the actual pressure. Okay, and if there's a fluctuation, and there's quite a lot of inconsistency with that pressure, there's a good chance it could be a faulty pin, what they call it, shaft. It could be sticking, okay? Good chance. And if he revs it up and goes back, and it's not going up and down, the pressure's not going up and down with the target pressure, again, it's indicative that there's a problem with that suction control valve, okay? So the pressure control valve is located at the rear of the high pressure pump. It sets the pressure of the fuel rail to suit the engine operating conditions, okay? So what the computer wants it to do, it will control the solenoid to get the desired pressure, okay? It has a spring-loaded valve that blocks off the fuel return passage until a certain pressure is reached. It then opens to allow the excess fuel to pass through the valve and to be returned to the fuel tanks through the return line to drop the pressure, okay? The electric solenoid operated by the ECU controls the opening and closing of the valve to regulate pressure. So it's just a regulator. It's done electronically to regulate the pressure in the fuel rail. But that's problematic and something that to be aware of. And sometimes they're not hard to do, sometimes they're a real pig to do, but I have changed a few of them.
Section control board.
So here we have our pressure sensor in the fuel rail, okay? We also have a pressure limiting valve for excess fuel. We have a problem with either of those sometimes that can control. We can have a problem that we're getting wrong. It's probably less likely, but it does happen sometimes that we get false readings from that. I've actually manipulated those. I had a car that wouldn't start, BMW. It would not start. I could not get fuel pressure up. I kept putting it down to the fact that this valve, okay, was showing the computer that there was enough pressure in the rail, so it was shutting off all the injectors, okay? So my thinking was, I manipulated the resistance in that. I disconnected it and put my own resistance in to get a resistance to resemble pressure. I wound the car up and it started. Okay? I had a faulty sensor, and that was my whole problem. It kept thinking there was no pressure there. So they do play out, but not very often. Sometimes these can leak, okay? If these leak, you know, they're meant to leak when you get to a certain pressure, right? But sometimes if they leak in this rail, at a lower pressure than desired, then we have too low a pressure in the fuel rail, and that sometimes can be our problem. We've got low pressure in the injection system, okay? The quickest way to find out if that is a problem is disconnect that pipe and wind the engine over and see if we're getting a strong flow of diesel coming out of it when we shouldn't be. We shouldn't be while we're winding it over. I could put a ball bearing or something in there and screw it back in and block it off, which I've done in the past, and all of a sudden I get pressure again. You know you've got a problem there. I've also lost pressure in the fuel rail because of a leaking injector. Again, we could do a flow test, like a back pressure test, and I'd say that's what Brendan found when he did his test, and he had all that fuel coming out. We can do that. Sometimes, if I can't get to the injectors, which are in some cases I can't, and at BMW I couldn't once. I don't know how the diesel people will think about me doing this, because it's a little bit, I don't know, maybe not desirable what I did, because I can damage the pipes. But I undid all the pipes, I stuck ball bearings in every pipe and screwed them up. And I wound the car over to see if I got fuel pressure, and I did. So then I disconnected one at a time and reconnected to the injector until I found out which injector was leaking. So that worked, okay? I had to replace those pipes when I finished though, because I probably distorted them. You're supposed to anyhow, but more so because I put a ball bearing in there. But I guess what I had to be careful was that I don't distort the flange on the end of there, on the actual rail itself. If I damage that, I'll never seal up even a new pipe. So I had to just nip them up without over-tightening them, just to be safe. Probably I'll tell you that with some caution. I did that and it worked for me, but yeah, there are some consequences if we're not careful, okay? Also, if this limiting valve needs to be replaced, okay,
Excuse me.
I can buy a limiting valve aftermarket, right? But the manufacturer tells me I can't just buy that, I have to buy the whole rail, which is quite expensive. I don't know, I've got away with it before, but the manufacturer, the OEM requirement is, if that plays up, you replace everything, okay? So I'll let you worry about that. If you want to risk an aftermarket one. There's different arguments of yes and no's to putting just the limiting valve on. Okay, pressure sensors. Pressure sensors in the rail is connected to the ECU. The ECU can control the pressure in the rail through the action of the pressure relief valve on the high pressure pump. Alright, so pretty much all that does is feedback to the computer so that the computer can try and control the actual pressure in the pressure rail to have the desired pressure. Okay. Flow limiters, these are connected to the common rail and the injector pipes. Fuel from the common rail passes through the limiters on its way to the injectors. The limiter consists of a housing with a spring-loaded valve. Under normal operating conditions, the valve is off its seat by the spring and there is high pressure in the common rail pipe. If the injector was to remain open, the spring in the injector pipe would drop, the high pressure rail would then move against the spring and close the valve. This would prevent pressure loss from the common rail and also prevent flow. So some of the injector lines might have a relief valve in them as well to shut off if there is a pressure, like stop all the fuel dumping into the cylinder and keep the pressure in the rail. So that's another thing. And our typical injector pipes, okay, how many times do we use them?
Well, recommended one use only.
Yep, that's correct. But people in the trade don't, okay?
Yeah.
But one day you get caught in it. And I've been caught once, okay? So, yeah.
Flexil tape.
I didn't replace them in my own car. This is the older Hilux I had. I reasoned that this is the first time the injectors have been replaced. I knew the history of the car from new, even though I didn't own it from new, but I used to service the car from new. So I knew the pipes had never been off. So when I took them off, I thought, yeah, we'll put them back on. I ended up having to replace them in Brew. I should have replaced them back then.
Isn't it like if it's left on the bench for too long, you need to do a high pressure clean?
You put covers over them so you seal them up.
Aye.
And you shouldn't have to worry then. Alright. So,
I just put it inside a Ziploc bag.
yeah, you can do that too. Send them up just to be safe too, like I said earlier.
Yeah. I usually put it inside a Ziploc bag. If I take those pipes out, I've got a Ziploc bag and just put it inside.
Yeah, good. That's fine. That's perfect. Yeah, I like that. So, two types of injectors that are used in common rail. One is a solenoid type, the other one's a piezo one. So that's just solenoid. I think that could be a solenoid type as well, but
yeah.
Solenoid type. Okay. Piezo are the stacked up. I think you weren't here yesterday, but we saw that all of the crystals that are stacked up in the injector itself. And when you put current on it, it will open or close, open or close. So each time you put current, it'll go one way or the other. That's why you don't pull the plug off of a piezo one, because if you pull the plug off and it stays open and you run it, it's going to run all that fuel into the engine, and you know like that.
Why is the difference between the two of them?
These might be the same, I think, but the piezo one uses crystals. This one uses a solenoid. See the solenoid? The green is a solenoid. The solenoid's electromagnet. When it's energized, it will then pull the pintle, see the long pintle? It will draw it back, and then the fuel can come down and go into the nozzle and through into the engine. Okay? These nozzles, because they're in the combustion chamber, they are accessible to the combustion afterburn that actually carbons them up. So there are times that they need cleaning. Putting good fuel, putting your premium diesel is a good thing, because they are more prone to have the cleaning additives in them than, say, the cheaper diesel fuels. Sometimes a diesel chemical in the fuel tank to help clean that carbon is a good idea. Okay.
So I want to ask.
Yes.
Is there anything that to make me know that which one is solenoid type, which one is?
Generally speaking, a piezo injector looks smaller. This actually This looks more smaller to me. That could be a piezo injector, I'm not sure. But they're normally a lot smaller even than that. Oh, you got a picture of one?
Oh, but it's the inside of that job.
Yeah, you
How
can
to know
Yeah.
outside, how
Yeah,
to know.
it's
you
probably bigger.
open and see inside.
So yeah, that's the solenoid, and that's the piezo one. And the piezo one has these crystals in there that actually lift the pin.
Once you see that car, that engine, and then you have to go and see
Yeah.
what.
I'm pretty sure this might actually be a solenoid one, actually, because it is a bit chunky here, but
The spring of it.
hard to know. The voltage in these solenoid and also the piezo are quite high voltage too. I think about 90 volts or something to activate the solenoid or the piezo. So we have to watch for electric shocks, okay? Okay, what causes these common rail diesel problems? Okay, we have problems with the quality of our fuels, okay? Particularly in Australia. In the Europe countries, they're looking at Euro 7 and Euro 8, right? We're still in Euro 5, I think, because our fuels aren't up to scratch. And for us to be able to run the higher emission requirements requires quality fuel that we don't have. I think I read somewhere that there's a year coming up where our government has regulated that our fuel supplies must meet certain specifications to bring the standard of our fuel up, so that we can meet more stringent emission requirements, okay?
I remember about like 15 years back, we had Ford Rangers came to Fiji,
Yes,
and just because it was programmed according to their fuel,
Yes.
and when it came to Fiji, because we got a lower grade fuel and it was all smoky, and they had to reprogram their computer according to the fuel in Fiji.
yeah, your fuel's probably like our fuel, rubbish.
Yeah.
Okay.
No, I mean, it's way more rubbish there, to be honest.
It's a UK.
Yeah, exactly.
Also, operating conditions, okay? When we drive the diesels for short drives all the time and we don't get the engine hot enough and, we're excessively in stop-start traffic and idling in long periods of time and all that, and we don't get the engine hot enough for long enough, all that contributes to problems with diesel engines. Common rail systems are with very high pressure and high temperature suffer from the fuel degrading the fuel, leaving deposits in the pump and the injector. And so we often get contamination from our unburnt combustion, okay, around the injectors, particularly the nozzles. We're getting a lot of heat from the fuel going back into the tank. We get our tanks low, the sediment in the bottom of the tanks can get pumped up. All those things are contributing to problems with our common rail diesel, let alone if we get contaminated fuel such as with water or something in it. So these problems will stick injectors, they'll cause piston rings to have carbon deposits on it if it's got too much fuel because of bad management and bad maintenance of the diesel system. I think also regular oil changes aren't done enough. We don't get our oil changes done. Why are the manufacturers going for such long oil changes? Is to sell the vehicles and to make out they're cheap to service and maintain after the sale. But they don't care once they reach that point after 5 years or 7 years because it's out of warranty. But boy, the cars don't last long after that if they haven't been maintained properly. All right, technician. Okay, a diesel engine has excessive vibration. Technician A says that the binding variable geometry turbo, which is VGT vanes, could be stuck. We haven't talked about turbos much, but in the diesels, particularly the newer diesels, they will vary. Okay, they have a electronic control rod or lever that will control the angles so that we can have higher boosts at lower RPM, but then we can have higher boosts at high RPM. Okay, so they swivel this plate and allow for the turbos to have a different boost at different RPMs so that it can run better at lower RPM and give us more performance at lower speed, right? they can gum up, and they do gum up with carbon and that after a while, okay? And they can stick, and they can cause problems. So this technician is saying a vibration, excessive vibration in the engine is caused by the turbo. But this one's saying a broken flywheel or flex plate could be the cause. What do you guys think? Who's right?
I think B is right.
You think B's right?
Yes.
What do you think, Brian?
Yeah.
All right. Can I ask you, do you know?
Anyway,
Can I
broken
ask you-
flywheel,
Yeah.
if a flywheel is broken, then the car wouldn't run.
Well, it depends what he means by broken. Let's call it a crack.
Yeah, like if it's like out of the center,
Yeah,
like
yeah.
sort of.
Yeah, not to that extent. It's just that it's become uneven because it's got a crack.
Yeah.
Okay, so we'll assume that's what he means. Probably a bad wording of the question. All right, but I'm going to ask you, why can't it be this one?
Because if the veins are clogged up, it has nothing to do with the vibration. It might affect your car in
Performance.
under power, or it might overheat your vehicle because there's not enough air circulating inside, but not with the vibration.
Cool. I just want to make sure that you understand and you're thinking like
It's those VGT ones are like a stepper motor ones.
Yeah.
They have the rods, so they control the vein inside.
That's right.
Yeah, where the turbine is.
Yeah. Good answer. Thank you. You're right, by the way. It is B. Oh, hang on. See? B. All right. What is the purpose of a common rail fuel system in a diesel engine? So it could be to deliver fuel at high pressure to the injectors, or it could be to regulate fuel flow to the engine, or it could be to remove air bubbles from the fuel system, or to increase the efficiency of the engine. I want Brian to answer that one. What do you think, Brian?
I think it should be D.
D. You think D. What do you think, Vinny?
A.
You think A? What do you think?
A.
What do you think?
B.
B. Well, everyone's got a different answer. Let's have a think of the question. Okay. Does an injector pump deliver fuel at high pressure to the injectors?
It does.
It does. So that's definitely correct. B. To regulate the fuel flow to the engine.
Mm-hmm.
Fuel flow to the engine. Doesn't it go to the injector?
No, it
Yeah.
goes before the injector, the fuel rail.
So to regulate the fuel flow, we're talking about the purpose of a common rail. So we're talking about the common rail.
Yeah.
Common rail.
Yeah, to regulate equal flow to all the four, the pressure on the equal. If you got four injectors.
All right. Let's ask this question. Well, let's come back to that. Okay, let's come back to that. Let's look at this one. To remove air bubbles from the fuel.
No, it won't.
Won't do that. And Brian said to increase the fuel efficiency of the engine.
I'll say yes.
All right. Remember, we're looking at these multiple choice questions. We're looking for the most correct answer too. So we're talking about the fuel rail. I'm going to come back to this one here. Regulate fuel flow. What regulates the fuel flow? Does the common rail regulate the fuel flow, or does the actual high pressure injection pump that has a suction control valve regulate the fuel?
High pressure, the fuel rail, because it has got a pressure regulator
It's
valve.
not a pressure regulator valve. It's a limiter.
Yeah.
It's like your air compressor, okay? If it builds up too much compressor, it's got a limiter that will lift off if it gets too high.
Yeah.
It's the same with the fuel rail. It doesn't regulate the pressure, but it stops it from getting excessive. So the fuel common rail doesn't regulate. It just maintains fuel in it at a certain pressure that's been generated by the fuel pump, which is regulated through the suction control valve or pressure regulating valve, okay? So I rule that one out. And increase fuel, yeah, common rail does increase fuel efficiency, there's no doubt about it, but the most correct answer is A. So A was the right one. That's okay. Oh,